Hello guys, welcome to Hardcoder. Today we are going to see the lead code daily challenge for the day 16th October 2022. It's time to the question. Lead code 1335 minimum difficulty of a job schedule. So the given problem statement is you will be given the list of jobs and you need to schedule the jobs for D days. So the difficulty of each job will be denoted in the array, that is job difficulty array. So and there's other conditions like you need to finish at least one task every day, so each day must be having at least one task to be done, and there's a condition that each job should be completed only if the previous jobs are completed. So when I discuss about the approach, we can able to find this out. And the difficulty of a job is sum of difficulty of each day. So the overall difficulty of the job schedule that we are going to schedule is based on difficulties of each days. So difficulty of each day can be considered as the maximum difficulty of the job done on that day. You will be given the job difficulty array and number of days for which the jobs need to be scheduled, and we need to find and return the minimum difficulty of the job schedule. So if we cannot able to schedule the given jobs for D days, you need to return -1. So let's try to approach this problem. So firstly you will be given the job difficulty, that is difficulty of each jobs. Here there are 1, 2, 3, 4, 5, 6. 6 jobs present here, and it is we need to schedule for 2 days. So let's consider 2 day, I mean it's a 2-dimensional array. Sorry, it's a array of size 2. So this is first day, this denotes second day. So first day, firstly we need to try every combinations possible for each day. So firstly we'll try to schedule this job number 1 into the first day and other jobs to the next day. That is 5, 4, 3, 2 and 1. So in this case the answer is going to be, so difficulty of this day is 6 because the maximum element for the day 1 is 6, and the difficulty of second day is 5 since the maximum difficulty of the second day is 5. So if we sum it up, the overall minimum, that is the final minimum difficulty of the job schedule that we have scheduled here is 11. So initially it will be 11 and we'll try other possibilities. So we'll add 5 here. I mean we'll schedule the first job, fifth, that is second job to the first day, and remaining jobs here in the second day. So in this case the first day's difficulty is 6 and second day's difficulty is 4. This is because the maximum difficulty of the difficult job of the first day and the maximum difficult job of second day, they sum up to 10. So this is the new answer we have found out, and we'll try other approach, other combination. So we'll take this 4, we'll take this job and we'll schedule it to here. So during this time the difficulty of the first day is 6 and the difficulty of the second day is 3, because the difficulty of second day is 3 because it is a maximum difficulty of any task, and the first day's maximum difficult job is 6. So when they sum up to 9, this is the newly computed answer, and we'll try with other combinations. We'll try to schedule the job with difficulty 3 to day 1. So the day 1's difficulty is 6 because 6 is the maximum value, and the day 2's difficulty is 2. So they will sum up to 8. This is the newly computed minimum difficulty, and finally we'll try the other combination. So we'll take this job which is having 2 difficulty to the first day, and finally we'll able to get the solution like 7. So this is the minimum difficulty a job can have. We cannot remove this one and put it here because if there is a condition that each day should be having at least one job. So answer for this question is 7. So here this answer is 7. We'll go to the second test case. So in second test case, there is 3 jobs and we have to schedule it for 4 days. Let's consider an array of size 4, and these are the days, and there is only 3 jobs for 4 days. So maybe we can put here 9, 9 and 9. So there is no job for the 4th day. So we can clearly see that there is a day cannot have a task. So this is an invalid job schedule. So we need to return -1. So we'll jump on to third test case. So we'll take a array of size 3. This is first day, second day and third day. We'll firstly place the first job here, second job here and third job here. So the difficulty of the job schedule is 1. The first day has maximum job difficulty as 1, and second day has maximum difficulty as 1, and third day has maximum difficulty as 1. So they sum up to 3. This is the minimum value of the job schedule. So we can clearly see that answer of this is 3. So we cannot have any other combinations except this job schedule. So how can we build this logic? So firstly we can have a point, we can have a recursive function. So we can today here I'm going to solve this problem using recursive solution, recursive approach. So firstly we'll pass we'll consider the first test case. So wait a second. So firstly let's say we have a function f and we are passing indexes 0, that is this 0th index, and the day and total number of day. So this is the function, and this is job index, and this is the day, this is total number of days. Job index, current day, total days. So our approach is going to be, firstly we'll firstly in the first function we'll check for the base condition, that is if number of jobs, let's say number of jobs n is less than the number of days to be scheduled, we'll return -1. This is the base condition, and we'll check with the other condition. So firstly our aim is to check for every combination. So in the function we'll find the remaining days for which jobs need to be scheduled. So firstly when we come to the first day, So the remaining day to be scheduled is 2, I mean 1. So first day will be scheduling this for this day, and the remaining day is 1. Remaining days is 1, and remaining job is remaining j, that is job, is 5. So what I have done here is, let's take this array, first day and second day. So firstly I have taken the first job and placed it here, and I'm going to find the other remaining days. So remaining days is going to be, there is only one remaining day and there is 5 other jobs left. So this is the this is what we have made, and we'll go to the recursive call to the next day. We need to find the next day, along with we'll increment the job index, so 1 and the next day and total number of days. And there we need to have another base condition, that if the day we are going to meet find for is the final day, we'll add up, I mean we'll find the largest task difficulty and we'll return it up. So this will be the case. Firstly, as I mentioned, the walkthrough of the first test case, we'll be writing up the solution. So we'll dive into the approach, I mean we'll dive into the coding session, so there you'll be getting the whole knowledge about this problem. Yeah, here I couldn't able to explain the problem here, so it will be clear in the coding session. So firstly we'll check for the base condition, that is, firstly we'll see the job count. So job difficulty dot, if number of jobs is less than days, will it simply return -1. Otherwise we'll return, firstly okay, we'll return min difficulty. We have a helper function, we'll pass the job difficulty array and the current jobs index and the day which we need to calculate job difficulty and the total number of days. So we can have this array as a global array. They are giving this because it will be easy for us. So job, so we'll be passing this to your helper function. So in the helper function we'll write the core logic here. So firstly the job index, and second the day, finally total days. So your base condition will be, if the day is I mean the final day, so let's call it total days. We need to simply find find the highest difficult job from the job index, that is, wait a second, so max difficulty is job difficulty of job index. So firstly, initially we'll consider the current index as the maximum difficulty, and we'll increment a job index. So while we'll iterate over the array till we meet the last index. So job index less than job difficulty will continually comparing with the max difficulty. Max difficulty job and we'll increment the job index. So finally we'll return the max difficulty. Else we'll find, first we need to find the remaining days. Remaining days can be calculated by total days minus current day, and current days maximum difficulty will be job difficulty of job index. So considering the job index to be scheduled to the current day, that is this current day will be having the job index, that is that job scheduled here, and we'll be checking if the job, I mean the check for every possible combination. So while remaining days, the job remaining, we need to firstly find the job remaining. Job remaining can be easily calculated by using job difficulty dot length, that is total number of jobs minus total number of assigned jobs. We are incrementing the job index pointer after we are assigning to the current day, and if the total number of jobs remaining, we using this expression we will be able to find the total number of jobs left, that is remaining, and this is the remaining days. If the remaining jobs is greater than the remaining days, we have a possibility to add to this current day. So we'll check for the, we'll update the current difficulty max of current max difficulty with job difficulty of current index, that is job index. And firstly we'll have uh, total difficulty as current max difficulty plus min difficulty of job index day plus 1 and total days. So what I have done here is the final total difficulty can be calculated by adding up the difficulty of the current day and sum of difficulties of the other days. That is, it can be found out by recursive call. So this recursive call will take care of the other days, finding the sum of other days difficulties. So after this we are trying with other possible combination. So after this, total difficulty should be minimum. So we'll compare the total difficulty till now with current max difficulty and difficulty of other days. and we'll increment the job index. So finally we'll return the total difficulty. So we'll check it up. Firstly, we are finding the number of jobs, and if the job is less than the day, we are returning -1. That is, this is an invalid case. We will be not able to schedule the job. And next, we are having a global. I mean, we are declaring the global variable, that is job difficulty array, and we are passing the return of we are using a helper function, and we are passing three variables, that is the job index, that is current job index, and the current day and the total number of day. So firstly, the base condition is if the current day is the final day, we are finding the maximum difficulty from the current index till the last index. So we firstly will assume the current index job as the maximum difficulty, and we are incrementing the job index, and we are checking for maximum difficulty till the end of the job difficulty array. So it is maximum. So we are finding the maximum difficulty till the end of the array, and we are returning the maximum difficulty. In case of other days, we are going to find the remaining days, that can be founded by total days minus remaining day. And if the we are assuming the current job index as the maximum job difficulty, and we are incrementing the job index, and total difficulty is the current right now is current max difficulty plus the other day's difficulty. So while while the jobs remaining, that is jobs dot length, that is if there is 6 jobs and we are assigned the current job to day 1, and there are 5 jobs left, so 5 is greater than remaining days. So will we are able to assign the current job, I mean the next job also, to the current day, and we are finding the total difficulty and incrementing the job index. So we'll try with sample test case. Sorry, current max. uh, so what I had one mistake. So firstly we'll find pass the 0, 1 and number of days. If the days the final day, we'll find the maximum difficulty. Okay, so we'll increment, I mean okay, and we'll first find out the remaining days and assign the current job as maximum difficulty. So we'll try with printing. So firstly it will be 5, then 5, 4, 3, 2. So okay, so what I have done mistake. So actually after assigning this current job to current day, we need to increment the job index, right? Yeah, it's working fine. So it's working fine here too, and we'll try to submit it up, but it won't work. Do you know why? Its time limit exceeded. This is because it's too it takes lot of time, because there is same values computing each time. So how to optimize this? So we can clearly see that the recursive calls are differing only by two parameters. So we can compute the DP solution for this approach. So we will create integer two-dimensional integer array DP, and we'll create it as first index is job index, so total number of jobs. So that is total number of jobs is n, and number of days b plus 1. So why we are having giving it as number of days plus 1? Because initially we will be passing the d. So it will be if we don't have as d plus 1, it will be index out of bound exception. So firstly we'll check if the value is already computed or not. If job index dp of job index and current day is not equal to null, we'll return the already computed value. Else firstly we'll have a temporary variable and store the current job index. We are storing this because each time when we increment the job index, we'll not be able to find the job index which we had before. So gp of, after computing the value, we'll store it to the dp, that is dp of temp and current day will be max difficulty, and in this scenario dp of temp and day will be total difficulty. So let's try with sample test cases. It's accepted, so we'll submit it up. That's working fine, guys. So the time complexity for this approach is big of n into n, that is n into m, and space complexity is same as n into m. It is because let's consider the n as number of jobs, m as number of days. So approach for this problem is it's a recursive approach and optimized using memoization plus recursion. So if we face this kind of questions in the interview or a competitive programming environment, firstly I'll highly recommend you to come up with the recursive approach. As we have come up with this question, we firstly need to come up with the recursive approach, and memoization will be very easy if you find the recursive approach. You just take the parameters and compute the same solution with memoization. Thanks for watching this video. I'm sure that you would have learned the concept very well. So thanks for viewing this video. Have a great time.